Hi, welcome to another video. Today, I wanted to talk about a new model called DeepCoder 14B. It's a relatively new and quite impressive coding-focused large language model. It's designed specifically for tasks involving code generation and understanding. At its core, it is a 14 billion parameter model, specifically a code reasoning LLM. It has been meticulously fine-tuned from the DeepSeek R1 distilled Qwen 14B base model. The fine-tuning process utilized distributed reinforcement learning techniques. Now, there's also a smaller 1.5 billion parameter version available if you're curious and want to explore that one. However, it's important to remember that due to the significantly lower parameter count, it obviously won't perform at the same level as its larger sibling. In this video, I'm going to be primarily focusing on the 14 billion parameter model. One of the standout achievements of this model is its performance on Live Code Bench. The model achieves an impressive 60.6% pass accuracy on this benchmark. This represents a substantial 8% improvement over the base model it was fine-tuned from. Perhaps even more impressively, this performance puts it in a similar league to OpenAI's O3 mini model, despite DeepCoder having only 14 billion parameters. Furthermore, a major plus point is that the model features open weights. It's also readily available on Ollama, which makes trying it out incredibly straightforward. The developers achieved this performance by fine-tuning, or perhaps more accurately, post-training the original DeepSeek R1 distilled model. They used a carefully curated training dataset consisting of approximately 24,000 unique problem test pairs. This data was compiled from several sources, including Taco Verified, the Prime Intellect Synthetic 1 dataset, and also incorporating data from Live Code Bench version 5 itself. For the training process itself, they employed a technique called Generalized Reward Policy Optimization, or GRPO. They also incorporated some specific improvements inspired by direct preference optimization, known as DAPO, which helped to enable more stable and reliable training, preventing common issues that can arise during complex reinforcement learning procedures. They have also specifically worked on lengthening its capability for long context outputs. This essentially means the model has been trained to think harder and process longer sequences of tokens more effectively. In practical terms, this generally translates to increased performance, especially on tasks requiring deeper reasoning or understanding of extensive code bases. You can think of it as the original distilled model, but enhanced with a higher capacity for sustained reasoning effort. Impressively, it also successfully generalizes this capability to even longer contexts when evaluated at a 64,000 token context length, still reaching that notable 60.6% accuracy, which is quite remarkable. The researchers mention that DeepCoder generalizes better to these long contexts compared to the base distilled model, partly thanks to a technique called overlong filtering used during training. However, there's a caveat. Its longer, more detailed responses can sometimes be truncated if the maximum output length is capped at 16,000 tokens, which, understandably, can negatively impact its scores on certain evaluations. This implies that if you intend to use the model but restrict its output generation to a maximum of 16,000 tokens, you might observe somewhat degraded performance compared to allowing it more room to generate its full response. The team has also shared benchmark results, and these benchmarks consistently show that DeepCoder is performing on par with OpenAI's O3 mini model and can even surpass it in certain specific scenarios. However, it's wise to take these direct comparisons with a small grain of salt, because the model was explicitly trained on some of the live code bench questions and potentially other benchmark questions as well, which could inflate its scores on those specific tests. But, regardless of the benchmark specifics, it demonstrably outperforms the original distilled DeepSeek model it was based on. To ensure the quality of the training process, they utilized code sandbox execution for verifiable rewards. This is a critical step when computing rewards for code-based reinforcement learning training. Essentially, they run unit tests on the code generated by the model within secure coding sandboxes. During each reinforcement learning iteration, their training batch is evaluated across a substantial 1024 different problems, and each of these problems features multiple unit tests. This creates a very demanding computational workload, requiring the scaling of over 100 coding sandboxes to run concurrently. This parallel execution ensures that the large volume of code generated by the LLM is accurately verified against the tests within a reasonable time frame. Currently, they employ two types of sandboxes for this verification: the Together Code Interpreter and a local code sandbox setup. It's also worth noting that this model is the result of a collaboration between researchers and Together AI. As mentioned, the model is conveniently available on Ollama. This means you can easily download it, run it locally on your own machine, and experiment with it, which is incredibly empowering. To get started using it, simply head over to the Ollama website. If you haven't installed Ollama yet, you'll need to do that first. It's usually a very quick process. Once Ollama is set up, navigate to the models page on their site. In the search bar, just type in DeepCoder, and you should see the model appear. Clicking on it will typically present you with two options: the 1.5 billion parameter model and the 14 billion parameter model, which, as we've discussed, is the primary one likely to deliver stronger performance. So, just select the 14B version, copy the provided command, usually something like Ollama run DeepCoder 14B, and then run that command in your local terminal. In just a short while, depending on your download speed, the model will be downloaded and ready to use, which is really quite awesome. Now, I've had the chance to test it out a bit myself, and my initial impression is that it is certainly better than DeepSeek's original distilled variant, especially in complex coding tasks. However, the reasoning process can feel a bit tedious at times. It occasionally takes significantly longer to generate responses, even for relatively simple tasks. This is somewhat characteristic of models trained for deeper reasoning. They sometimes overthink problems where the original DeepSeek reasoning variants perhaps excelled because they were less prone to extensive deliberation on simpler queries. So, while the depth is good, this tendency to overthink isn't always ideal. Despite this, it remains a genuinely great model for its 14 billion parameter size, demonstrating really capable performance overall. One area where it seems a bit weaker, though, is tool calling or function calling. It appears to struggle sometimes to integrate smoothly with interfaces or frameworks like Cline or RuCode, possibly due to the verbose thinking traces or internal reasoning steps it generates. Still, for straightforward conversational interaction using interfaces like OpenWebUI or similar chat platforms, it works wonderfully. So, that's definitely a positive aspect. I really like this model, and you can surely give this a try and let me know your results in the comments. Please subscribe to the channel and share your thoughts as well. I'll see you in the next video. Bye.